Okay, now we're going to simplify irrational numbers, imperfect roots, and we're going to, even if they have a variable, and we're going to simplify imaginary numbers when they have the imaginary I. All right, first we're going to take this radical. Well, the first thing you do is check to see if 512 is a perfect square. If you type in on the scientific calculator the square root of 512, you'll see that you'll get a decimal amount. All right? So that doesn't work. The other thing you need to remember, the whole point to simplifying is you want to find the square root of a perfect square. Well, if b is to the first power, b is never going to be the perfect square. So b will be part of the final answer. You just have to start dealing with 512. And one good tactic to use is a factor tree. Since 512 is even, divide 512 by 2 and you get 256. What you could do at that point is check. Is 256 a perfect square? It is. The square root of 256 is 16. So then what you have is 16 times the square root of root b. And that would be your final answer. However, if you didn't think to check that 256 is a perfect square, well then you would do 2 times 128, then 2 times 64, and then hopefully you would recognize that 64 is a perfect square. So let me choose a different color. You would then have 2 times 2. There's a perfect square. Times 2 times 64 times b. Well, 2 times 2 is 4. The square root of 4 is 2. The square root of 64 is 8. So 8 times 2 is 16. And then the only thing that's left under the radical is 2b. So that's a couple of ways to get there. All right, I'm going to cover all of that up. Now, 162. Look at this as n cubed. Well, n cubed will never get to the fourth power. So your final answer will have an n cubed in it. And I think what I did below is the factor tree. So 162 is even, so 2 times 81. Now 81, if you add up 8 plus 1, you get 9. So I know that, and because 3 is a factor of 9, 3 is a factor of 81. So divide 81 by 3, you get 27. 3 goes into 27, 3 times 9, and then 3 times 3. And then look at, you have 3 4 times, or 3 to the fourth power. So you're going to do the fourth root of 2 times 3 to the fourth power times n cubed. Well, 3 to the fourth power, and that's the fourth root, that cancels out, and the 3 comes out. And now you have 3 times the fourth root of 2 n cubed. And all it's asking you to do is simplify. That's the most simplified version. All right, so now what we're doing is operations. So we're adding or subtracting roots. Well, radicals, when you add or subtract, have to be the same. So you could add root 2 plus root 2. Well, there's one root 2, there's another root 2. So you would have 2 of those root 2's. But if you tried to add root 2 plus root 3, you can't. They have to be the same radical. So what we could try to do is to simplify root 18. Well, remember, root 18 is the same thing as 18 is 2 times 9. Well, the square root of 9 is 3. So now what we have, 3 times 3, we have 9 root 2, subtract 2 root 2. Well, 9 subtract 2 is 7 root 2. And that's all there is to this one. All right, let me cover that up. Well, now we have a negative root 18, and we know root 18 simplifies. Root 3 is prime, so that's as simplified as it gets. Root 12, remember what you're looking for. You're looking for perfect squares. So when you simplify 12, 4 is a perfect square, so we're going to choose 4 times 3. Notice we don't use 6 times 2 because 6 isn't a perfect square. So a perfect square factor of 12 is 4. And then square root of 18 is 2 times 9. And then look at what happens. Square root of 9 is 3. So now you have 3 times negative 2. Square root of 4 is 2. So this is what we have. We have negative 2 times 3 root 2, subtract root 3, and then we have 2 times 2 times the square root of 3. So negative 2 times 3 is negative 6 root 2, subtract root 3, plus 4 root 3. And now these two both have a root 3, so that's 4 plus that invisible negative 1. And what you end up with is this negative 6 root 2 plus negative 1 plus 4 is 3 root 3. All right, so that's simplifying radicals. Now we're going to simplify when there's division involved. This is called rationalizing. So rationalize is the verb, do this. What we're doing is rationalizing the denominator. So you never want an irrational number in the denominator. So any type of square root or cube root or fourth root or whatever in the denominator has to go away. It's the denominator that cannot have irrational numbers. The numerator can, the denominator cannot. So the way to get rid of a radical in the denominator, so for example, if you had 1 over root 2, a way to get rid of a radical is to multiply it by itself. Because root 2 times root 2, think about this, is root 4. Well, the square root of 4 is 2. So when you rationalize a denominator, you multiply the radical times itself, the radical sign goes away, leaving the number. So now what you have is 1 times root 2 in the numerator. And this is now a number we can deal with. All right, I'm going to erase all that. So we have to get rid of the radical. Well, the problem with this is root 27 can be simplified further. Root 27 is the same as 9 times 3. Well, the square root of 9 is 3. I think I showed you the quick route, and then I'm going to show you the... Oh, yeah, I think I did that down here. So this is what we have. Well, you can simplify root 15. Root 15 can be rewritten as root 3 times root 5. And then look what happens. The root 3's cancel, leaving root 5 over 3. Now this is the quick route. If you didn't do it, if you didn't recognize that you could break radical 15 down, then we're going to do this next route. We still have to get this root 3 out of the denominator. So you would multiply top and bottom by root 3. Remember what we said, when you multiply a radical times itself, the radical goes away, leaving the number. And now you have 3 times 3. But root 45 is the same thing as 9 times 5, which is what I did right there. And then the square root of 9 is 3. So now what you have is 3 root 5 over 9, and then 3 and 9, they both have a 3 in common. This 3 cancels to 1, this 9 cancels to 3. So the final solution is root 5 over 3. That's what we also ended up with right there. A little bit longer route, but it works out the same. All right, so notice what we have here. In the denominator, we have root 9. Well, that's just 3. There's nothing else to do. So if you're paying attention, sometimes that's all the work you have to do. All right, this next thing that we're going to be doing is rationalizing when there is a sum or difference. Notice in the denominator, we have 2 plus 4 root 2. We have 4 plus 5 root 3. Well, you can't just multiply top and bottom by root 2. If I did that, notice this is a parentheses. You'd have to do the distributive. Well, root 2 times 2 is then 2 root 2. You'd still be stuck with a radical. So there's this method, it's called the conjugate method. A conjugate is when you have two terms being added, the conjugate is then the two terms with a subtract sign. So each parentheses has an x and an x, each parentheses has a y and a y. The only difference is one is a plus sign, one is a subtract sign. When you multiply that, instead of having 4 terms that simplify to 3 terms, you end up with the first thing squared, subtract the second thing squared. Because look if you ended up doing x times negative y, you have negative xy, and then if you multiply y times x, you'd have a positive xy, and those cancel. So the only thing that you would have left is x times x, which is x squared, and positive y times negative y, which is negative y squared. The conjugate method cancels out those middle terms. So you're going to multiply top and bottom by the conjugate. This would be 2 subtract 4 root 2, and I'm sure that's what I did here. Oh, I left it blank. There we go. So 2 subtract 4 root 2. All right. Well, the cool thing about conjugates is in the denominator, you just take the first thing and square it, put a subtract sign, square the second thing. So the first thing in each parentheses is 2. So in the denominator, we put 2 squared and then 4 root 2 squared. Well, 2 squared is 4. 4 squared is 16, and then root 2 squared is 2, and then you have 4 subtract. Well, 16 times 2 is 32. Oh, I think I made an error down below, so I'm going to finish doing it this way. So what you have now in the denominator is negative 28. All right, in the numerator, 2 times 2 is 4. And then 2 times negative 4 root 2 is negative 8 root 2. Well, 4, negative 8, negative 28. First of all, we don't want a negative sign there, so we typically multiply or divide everything by negative 1. But 4, negative 8, and negative 28 all have a 4. So I'm going to factor out a negative 4 from each of those. So 4 divide negative 4 leaves positive 1. Negative 8 divide negative 4 leaves positive 2 root 2. And then down here, negative 4 times 7. So that's what we have left. 1 plus 2 root 2 all over 7. So that would be the final answer. 1 plus 2 root 2 all over 7. All right, I'm going to cover all this stuff up. So I give you that information as a warning that you can pause the video if you want. Let me get rid of it. All right, so the conjugate to 4 plus root 5 is 4 subtract 4 plus 5 root 3. I don't know what I said. I think I said root 5. 4 plus 5 root 3. The conjugate is 4 subtract 5 root 3. And remember what you do in the denominator. You square the first two things. So it's 4 squared. Here, I'm going to change this to black. The first thing is 4. The second thing is 5 root 3. And then 4 squared is 16. And then 5 squared is 25. Root 3 squared is 3. You've got 16 subtract 75, which should be negative 59. All right, and then up here, we did a double distributive. We did 4 times 4, and then 4 times negative 5 root 3. Then we did negative 4 root 2 times 4, and then negative 4 root 2 times negative 5 root 3. Whoops. Four times 4 is 16. 4 times negative 5 root 3 is negative 20 root 3. 4 root 2 times 4 is, negative 4 root 2 times 4 is negative 16 root 2. And negative 4 root 2 times negative 5 root 3, you get 20, positive 20. And then root 2 times root 3 is root 6. But because this is a negative, we're going to multiply or divide everything by negative 1. So this sign will change, this sign will change, this sign will change, this sign will change, and this sign will change. So doggone it. That final simplified answer, this changed, this changed, this changed, this changed, this changed. So that's the final answer right there. Let me get rid of this. And that's a simplified, because notice this doesn't have a radical. This has root 3, root 2, root 6. None of those are the same. So you cannot add any of those terms together. And 59 is prime. So 16, 20, 16, 20, they share a factor, but they don't share a factor with 59. So that's as simplified as it gets. All right. I think I'm going to end this one, and then we'll do the imaginary video, imaginary numbers next. All right. That's it for this one.